one of the ways that we can evaluate theoretical probability is by creating a diagram called a tree diagram. And so what you see here at the top of the screen, this piece right here, this is a tree diagram. Okay? And it's just a useful way of trying to map out all of the possible theoretical outcomes that you could get for a particular situation. Okay? So let's do an example or a couple of examples, and we'll start off by making a tree diagram of flipping a coin. Okay? And so in example 2 here it says create a tree diagram to determine the number of possible outcomes if 2 coins are tossed. Okay? So we have 2 coins. So let's say if we flip that first coin, okay, so here's our first coin, and here is our second coin, okay, and each one of these situations represents a single flip. So if I'm making a tree diagram, okay, if I flip one coin, how many possible outcomes are there if I flip a single coin? Well, there's 2. I could either flip and get a head, or I could flip and get a tail. Okay, so there's 2 possible outcomes if I'm flipping a single coin. However, if I throw a second coin in the mix, suddenly the number of possible outcomes increases. If my first coin ends up being a head, when I flip that second coin, I could either get a head or I might get a tail. Okay. However, if I flipped the first coin and I got a tail, okay, when I flip the second coin, I might get a head or I might also get a second tail. Okay, so I've just flipped this coin twice. So in this instance, I want to actually calculate the total number of outcomes that there are. So you want to read this map, this tree diagram, either from the left to the right, or you could read it from the right to the left, but you want to map out all of the possibilities. So I'm going to start here with my first coin flip. Okay, and let's say my first coin flip was a head. Okay, I then move up the tree diagram, and my second option was also a head. Okay. If my first flip was a head, I could move down the tree diagram. Okay, and so my second option result could have been a tail. Okay, and so by tracking the outcomes that are possible, okay, you can actually come up with a list of all of the theoretical outcomes that you may end up getting. Okay, likewise, if my first coin ended up being a tail, my second coin flip I could have gotten a head, and if my first flip was a tail, my second one might have been a tail. Okay, so in total there are actually 4 possible outcomes. Okay, okay, so there are 4 possible outcomes when making this tree diagram. So let's use the information that we have here to complete this chart that's underneath. Okay, so we're going to use the diagram above. Okay, so what's for number 1 says what is the probability of only getting one head? Okay, so I'm going to mark this as red. Okay, so if I only get one head, all right, well, this answer happens to only have one head in it, and this answer only has one head in it. Okay, so out of all of my answers, only 2 of them, 2 of the 4, end up being resulting in a single head. Okay, so 2 over 4 in lowest terms is 1 over 2, which is equal to 0.5, which is equal to 50%. Okay, so let's take a look here at question number 2. What's the probability of only getting one tail? Well, the probability of only getting one tail happens to be the same 2 options. Okay, so here I get 2 out of the 4 results were only one tail. 2 out of 4 in lowest terms is 1/2, which is equal to 0.5, which is equal to 50%. The next question says, what's the probability of getting 2 heads. Okay, well, if I look at all of my options, only one of them meets that criteria. Okay, and so 1 out of the 4 meets that criteria. 1 out of 4, 1 over 4 is already in lowest terms. So we'll convert that into a decimal, which is 0.25. And we can also convert that into a percentage, which is 25%. Finally, for question 4, it says we need to get at least 1 tail. Okay, and so we'll mark this one as black. So any of the outcomes where I got at least 1 tail is fair game. So I got at least 1 tail here. In fact, I got 2 tails in that last trial. I got at least 1 tail here where I had a tail and a head. And I have at least 1 tail here where I had a head and a tail. The one at the very top where I have 2 heads, I got 0 tails, so that doesn't count. Okay, and so my probability there is 3 out of the 4 outcomes. I just count up the number of black ticks that I have here. I've got 1, 2, 3. So 3 out of the 4 results, I got at least 1 tail. So 3 out of 4 is equal to 0.75. So 3 divided by 4 is 0.75, which is equivalent to 75%. Okay? So using that tree diagram can be a really useful way of mapping out all of the theoretical possibilities that you could get in a situation.